Hi there, welcome back to Basic Math for Economics. In this video we're going to talk about integrals, and specifically using an integral to calculate consumer surplus of a function. So let's actually jump right in. I've got a little bit of a setup right here. So normally when we do consumer surplus, if we get nice linear demand functions and linear supply functions, we just use triangle formulas or trapezoid formulas if need be. But what would happen if we didn't have a linear demand function? So this function I'm giving you right here, the demand function is 10 divided by price minus 1. That's our quantity right there. And it's going to give us this little curve right here that's got some slight curvature to it. So to make things simple, let's first assume that the equilibrium price in this market were equal to 5. Right there. All right. So we know that this upper area is going to be our consumer surplus, but we need to figure out how to calculate that. So the first thing we're going to need to do, though, is calculate this vertical intercept right here. And we can do that by figuring out for what value of p does our demand function equal 0. So I need to know 0 equals 10 over p minus 1. Well, that's 1 equals 10 over p, or p equals 10. So this tells me that my vertical intercept is going to be 10. So since we have a curve, we can still get this area. We just need to use an integral. In fact, and again, we're working a little bit sideways right here. If I'm going from 5 to 10, the area underneath this curve, and remember the curve I'm looking is to the left, not downward, is just going to be the integral from 5 to 10 of my demand function. So that's 10 over p minus 1 dp. So if I just integrate this and then plug in my bounds, that's actually going to give me the area of this underneath this curve right here. And this is actually an integral that we can do. So let's figure this out. Now the first thing I could do is I could actually break this up into two integrals if I wanted to, but I'm not going to do that. We're just going to do this all at the same time. But let's integrate this first term right here, this 10 over p. All right, so I know that the integral of 1 over p is the natural log of p. So really I could just pull that 10 out of the integral and not worry about it. So this first term is actually going to be 10 log p. That's my integral right there of that first term. Now let's do the second term, minus 1. So the integral of a constant is just that constant times your integrand, the variable you're integrating for. So this minus 1 becomes minus 1p, or just minus p in this case. And then I still have my bounds between 5 and 10. I need to work with those as well. So that's it. That's the integral right there, 10 log p minus p. From here, all I need to do is plug in my endpoints, my 5 and my 10. Plug in the final endpoint and subtract the initial beginning point. So this is just going to be 10 times log 10 minus 10. Then all of that minus, I'll use the second line right here, 10 log 5 minus 5. Close my brackets. Let's actually give myself a little bit more room. All right, well, I can use a calculator to figure this out. So from this first term, it's 10, and then the log of 10 is just equal to about 2.3 minus 10. Then 10 times the log of 5, which is the natural logarithm of 5, is about 1.61. And then minusing a minus gives me a plus 5. So this is going to be 10 times 2.3 minus 1.61, then minus 10 plus 5 minus 5. So that's 10 times 0.69 minus 5. So 6.9 minus 5. That is going to give me 1.9. And that's it right there. That is the consumer surplus of this function of $1.90 approximately. But that's really it. Whenever we're dealing with a situation where we have a curve for our demand function, all we need to do is go through and we integrate. And again, we're dealing with underneath the curve, but from the perspective of economics, our dependent and independent variables are switched. So we have to remember to take that into consideration. You could actually use an inverse demand function to get the same effect. You just have to remember the bottom right here. That'll work too. but it's usually easier to work in this direction, and good practice as well. So anyways, that's all for this video, and thanks for watching.